Okay, moving on here in our review, we'll take a look at problem number 3 as we continue our topic of composite functions. We're going to look at decomposition. So we just did composition, where we were substituting one function into the other. So we were taking two and putting them together to make a new one. Well, now with decomposition, we're going to go the other way. We're going to take one and break it up into two. So in this one, let's read through the directions. It says for each function h of x, down below, there's two examples here we're going to look at. Find functions f of x and g of x such that h of x will equal f of g of x. So it'll equal the composition function, f composed with g. Right? So again, what is f of g of x? That's f circle g of x. So that's our restriction. And it says neither of the new functions may be the identity function, which is y equal x. So we can't use y equal x as a function. But here's our example. Again, we want to take h of x and want to break it up into f of x and g of x. And since we want h of x, right, our restriction, since we want h of x to equal f composed with g of x, right? That's our restriction here on this composition. And we need to find f first. So g is going to have to go into f, right? So that implies find f of x, then g of x. All right, so this will be what we call our parent function. So how we do it in decomposition. So you can have more than one answers. Answers may vary, but we'll show you how to go about finding these two functions. And when we're looking at our function, we want to know what type we're dealing with first. So when I say that, are we dealing with a rational function? Are we dealing with a radical function, an absolute value function? Right? So what type of function do we have in front of us? Well, if you look at this problem, we have a radical function. Right, we have our x term here in the radicand, right? We have 5x cubed plus 8 sitting inside the square root, right? It's a square root function. So to find f of x, right, our first step, all right, we're going to let x equal that. All right, let's let x equal 5x cubed plus 8. All right, so that would imply f of x would equal the square root of x, right? And again, if you want, let's put it in the same color. Make it a little easier to see here. So that implies f of x would equal the square root of x. So again, I've taken out 5x cubed plus 8, and I plugged x into it. All right? So again, we replaced, I'll make a note. We replaced the radicand, 5x cubed plus 8, with x to create a new function of x. All right? Now, with that said, now we're ready to find our second function. So now we need to find g of x. All right, now to find g of x, this is the easy part. Whatever we took out, all right, we've got to let that be the other function. All right, so that's going to imply g of x would have to equal 5x cubed plus 8. So whatever we took out, so 5x cubed plus 8, all right, would have to be the other function. All right, so I'm going to make a note right beside this. All right, so right here beside it, let's make a note of that. All right, whatever you replaced, whatever was replaced with x must be g of x. All right, so now we could check it. So now I've got my two functions. All right, so again, there's my answer. So again, f of x equal the square root of x, and g of x equal 5x cubed plus 8. So there's my pair of functions. All right, and again, you want to check that. Let's go ahead and check it using composition. So we can go back to our composition step. So let's check real quick. All right, so again, f composed with g of x is supposed to give me h back. So that's f evaluated with the g of x function. So that would be f of 5x cubed plus 8, which is equal to the square root, right, of 5x cubed plus 8 as you plug in that g function. And you see, after we plug that in, we're right back to our original function, which equals h of x. So it does check. So we were able to get our original back, right? It checks. All right, so that's decomposition, creating a pair of functions based off the original. So what we're asking ourselves to do in decomposition is, where do we want to plug our domain variable x into our given function? We want to plug it in to wherever our function is taking place, whether it's in the denominator or rational, whether it's in a radical like this one. All right, find out what we can do to replace, and we'll let g be the other. So let's see if we can take that over to example b. In b, we're given a rational function. So let's do the same thing. We want to find f of x, right? Then we want to find g of x. That's the question. All right, so again, first step. Step 1, let's go find f of x. All right, now I'm going to do that by replacing the denominator. So again, this time we're not doing a radical function. We're dealing with a radical function. All right, so I'm going to let f of x be x. So that implies f of x is equal to 9 divided by, and I'll plug it in now, 9 divided by x. So the denominator, we replaced x plus 4 with x. Let's go make that note here beside it. Replaced x plus 4 with x. All right, now we go to our g function. So whatever we replaced, right, so that implies g of x, right, will equal 9 divided by, right, well, not 9 divided by, will be what? X plus 4, whatever we replaced. So g of x will be the x plus 4 function. All right, I'll make that note, put it here beside it. So here are my pair of functions. So I've got my decomposition. All right, so my answer, so again, f of x is equal to 9 over x, and g of x is equal to x plus 4. So I found my pair of functions, all right, whose composition would give me h back. So again, if you were to check, all right, so if you were to do your check step here beside it, wouldn't take long to check it. All right, f composed with g of x equal to f of g of x, which is equal to f of x plus 4, which is equal to 9 divided by x plus 4, which equals h of x. So it does check. All right. So again, that's right, looking at decomposition. Right. So we'll stop there. We'll get a stopping point, then we'll go to our next topic, which is module 11, getting into inverse functions.